In this lesson, we are multiplying monomials. You'll learn how to multiply monomials and simplify expressions involving powers of monomials. Why does doubling speed quadruple braking distance? The table shows the braking distance for a vehicle at certain speeds. If s represents the speed in miles per hour, then the approximate number of feet the driver must apply the brakes is 1 over 20 s squared. Notice that when the speed is doubled, the braking distance is quadrupled. An expression like 1 over 20 s squared or 1/20th s squared is called a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. An expression involving the division of variables is not a monomial. Monomials that are real numbers are called constants because they can't change. Now, example 1 has 5 parts. In your textbook, this would be 5 separate questions, but we're doing it all in one so you can see the pattern. Determine whether each expression is a monomial. Explain your reasoning. Okay, A, is it a monomial? I have 17 minus s. That would be a no because it involves subtraction, not a product of two variables. So that would be called actually a binomial. I'm getting ahead of us, but it's coming soon. For part B, we have 8f squared g. That one is a happy yes. It is a product of a number and two variables. Now, 3/4 might throw some people off because that's literally 3 divided by 4, and we said we can't have division. But the problem with division doesn't happen with numbers. It is if we have a variable in the denominator. That's a no-no. So this is a yes because it is a real number, 3/4. We could plot it on a number line. So that is another example of a constant, just like 3 or 4. And for part D, we have xy. And that's a definite yes because it is the product of two variables. So that is okay. Now that we have looked at identifying what is a monomial, we're going to look at how to multiply two or more monomials. It's always a good idea to start with what you know, and it says recall that an expression in the form x to the n is called a power and represents the product you obtain when x is used as a factor n times. The number x is the base, and the number n is the exponent. So in 2 to the 5th, 2 is the base, 5 is the exponent. So that means 2 is used 1, 2, 3, 4, 5 times, and they multiplied it out and it's worth 32. But this is the part we're really interested in. 2 to the 5th literally means 2 times itself 5 times. So if we make up our own problem and we look at 2 squared times 2 to the 4th, that'd be 2, I'm trying to use my white for the times 2 times 2 times 2 times 2 times 2. I gave up. Okay, so I've got all together 1, 2, 3, 4, 5, 6 factors of 2. Now, if it seemed a little bit silly to you that I counted those, you're right. I could have just said that was 2 to the, here's my 2, and here's my 4. So I could just call that 2 plus 4, which is, of course, the 6 that we already had. Let's make up another one, see what we get. Okay, if we do 3 to the 3rd times 3 to the 5th, we'd have 3 factors of 3 times 5 factors of 3 so altogether I have 3 to the 3 plus 5, or 3 to the 8th factors of 3. Now, I know we could put that in a calculator and evaluate it and get a nice number, but that's kind of not the point. The point is we're looking for the pattern. We could have x's, we could have y's for our base, it doesn't matter. The whole pattern is, oh, here we come. If we're multiplying a power times a power, we're going to add the exponents. Now, what I wrote in the blue is a nice informal way to remember what we do. Formally, we could say to multiply two powers that have the same base, add exponents, or for any numbers a and all integers m and n, a to the m times a to the n equals a to the m plus n. Or, for example, with numbers, a to the 4th times a to the 12th equals a to the 4 plus 12, or a to the 16th. So for our first example like that, we're going to simplify r to the 4th times negative 12 r to the 7th. Okay, there's no coefficient in front of the r to the 4th. Coefficient is just a fancy word for number in front of the variable, so negative 12 is the coefficient of the r to the 7th term. Well, I said no coefficient. You can always say a coefficient is 1. That's easy. 1 times negative 12, then it's the product of our coefficients. And then we're going to multiply our two variables. They use the commutative property to rearrange and the associative property to group. We use our product of powers rule. 1 times negative 12, of course, is just negative 12. And then we have r to the 4 plus 7, which power times power, we add exponents, we get negative 12 r to the 11th as our final answer. To simplify the expression 6cd to the 5th, 5c to the 5th d squared, first we're going to regroup things, reorganize them. So we have the product of the coefficients, 6 times 5, the product of the c's, c times c to the 5th, d to the 5th times d squared, and that used both the commutative with reordering and the associative with putting our parentheses in. And then this is the easy part, 6 times 5 is 30, woot woot. And then the product of powers rule, power times the power, we add exponents, so we have c to the, there's not a number written on this one, so we can always use a 1. So 1 plus 5 and d to the 5 plus 2. And of course we know 5 plus 1 or 1 plus 5 is 6 and 5 plus 2 is 7, and so our final answer is 30, c to the 6th, d to the 7th. We can use that definition of exponents to look at another rule, which is called power of a power. We're going to start off developing that one the same way. If we do 3 squared to the 4th, we need to have our 3 squared written out 4 times. And we can apply the product of powers rule that we just learned. So that would be 3 to the 2 plus 2 plus 2 plus 2. Okay, but that's kind of silly because we know that repeated addition is the same as multiplication. So that'd be the same as 3 to the 2 times 4 equals 3 to the 8th. So we have a new pattern developing. See if you can see the pattern developing in this one. If we have y to the 5th cubed, we need to take our y to the 5th, multiply it by itself 3 times, which we know is the same as y to the, I'm going to skip right ahead to the 5 times 3, which is y to the 15th. So our rule is power of a power, we want to multiply the exponents. To find the power of power, multiply exponents. For any number a and all integers m and n, a to the m to the n is the same as a to the m times n. Or, for example, k to the 5th to the 9th power is the same as k to the 5 times 9 or k to the 45th. So they want us to simplify 2 to the 3rd, raised to the 3rd to the 2nd. Power of a power, we said we multiply exponents. Well, 3 times 3 is 9, and 9 times 2 is 18. Now, you could put that in a calculator and get to the 18th as 262,144, but for our purposes at this point, we're wanting to learn those exponent rules. So I would prefer to see 2 to the 18th is more handy for our purposes. Let's look at a couple more examples to develop a pattern for the power of a product. we look at xy to the fourth, we would have xy times itself 4 times, which if we combine our commutative associative properties again, we could group our x's and our y's. So we end up with x to the fourth and y to the fourth. I guess we don't need those parentheses. We could just write it as x to the fourth, y to the fourth. Let's look up another fake one like that. If we have 2ab to the third, we're going to multiply 2ab times itself 3 times. So this time we're going to end up with 2 to the third, a to the third, b to the third. I seem to see 3 3's. 2 to the third, 2 times 2 times 2 is 8. And we can't do anything about the a and b. There's going to be a to the third, b to the third. To me, this just looks like an extension of our power of a power rule. They say to find the power product, find the power of each factor and multiply. For all numbers a and b and any integer m, ab to the m is going to be a to the m, b to the m. Or if we have, this is a good one, negative 2xy cubed, we're going to take the negative 2 and cube it, which negative 2 times negative 2 times negative 2 is negative 8. And then we're going to cube each of our variables. So that's just going to be 1 times 3 is 3, and 1 times 3 is 3. So they decided to connect to geometry now. Find the volume of a cube with a side length s equals 5xyz. Just in case you need a refresher, volume of a cube is the length of a side cubed. So we need to take the length of our side, which was 5xyz, and cube it. So we take each one of our, and I could call them numbers, even though some of them are variables, because a variable stands for a number, and we're going to cube them. So we have 5 cubed, x cubed, y cubed, z cubed. 5 cubed is 125, and then we just have our x cubed, y cubed, z cubed. Now, so far, the 3, counting my little mini examples, 1, 2, and now this one, 3 examples we've looked at have all had variables that had only exponents of 1. Let's look at one that has exponents other than 1. You don't have to do this one on your own. We're doing it together. Breathe. It looks pretty complicated. Okay, we have 8 g cubed h to the fourth squared times 2 g h to the fifth to the fourth. Okay, power of a power, we can multiply exponents. So all I did was multiply. 2 times 2 is 4. Everything else I just copied down. Now we don't need these brackets anymore, so they are gone. We just have 2 sets of parentheses now. It's better already. Now, both of our exponents here both happen to be 4s, so we're going to use our power of product rule. We're going to have 8 to the fourth, g cubed to the fourth, h to the fourth, 2 to the fourth, g to the fourth, h to the fifth to the fourth. And they used a calculator, and they got h to the fourth is 4,096. 2 to the fourth is 16. Power of a power, we multiply exponents, so 3 times 4 is 12. 4 times 4 is 16. 2 to the fourth, they use a calculator, and they got 16. Well, that you could do in your head. And 5 times 4 is 20. Now, when I do problems myself, I tend to skip this step. They just went ahead and used a commutative property and put likes together. So on the calculator, they multiplied the 4,096 times 16. And then for our g's, we have power times a power. We add exponents. So 12, wrong button, plus 4 is 16, and 16 plus 20 is 36. So that's our cute little final answer, finally. Here's a nice little summary. To simplify an expression involving monomials, write an equivalent expression in which each base appears exactly once. There are no powers of powers left to simplify, and of course all fractions are in simplest form. That's kind of a given always and forever. Well, happy simplifying monomials.